Hi everybody, welcome to the session today with Ed Chan. Ed's based over in the States, and Ed's going to join us to talk about workflow architectures with humans in mind. So it should be a really good session. I'll let Ed have as much time as possible to talk, so I'm just going to pass it straight over to you, Ed. And if you have any problems, just let me know, and I'll just be watching in the background.
Sounds good. Thank you.
Thanks.
Yeah, welcome everybody. My name's Ed. Thank you for the introduction. That was lovely. And thank you for joining us in the DDD events this year. Before I hop into my presentation, just a reminder of everybody: be nice to each other. Treat each other as a human being. Be good human. Also, please donate to the National Museum of Computing. Without them and the list of sponsors, this kind of events won't happen. So make sure to thank the people who makes this happen so that we get to see each other's faces or listen to each other every year. And the last thing, make sure to spread the event. You like it, you don't like it, go to talk about it. I think people will love to hear your feedback throughout the events. Cool. So with that in mind, welcome to the presentation, Designing Your Workflow Architecture with Humans in Mind. Lots of big words. Don't worry, we're gonna go through it, we're gonna define all of them, and we're gonna just, talk about workflow architecture. Before, and my experience in FAST is what really brought me into this whole topic. FAST is an e-commerce company, and when you're in e-commerce, lots of things happens, right? So having that workflow architecture, learn that in FAST, really, it was really inspiring. It started letting me to think about, like, one, how do you perfect it? How do you make it better? And two, what other stuff that I can do with this workflow architecture? And that really opens up, my mind. So we going through, so I separate my presentation in 4 parts. First we're gonna just look at it together. We're gonna reinvent the wheel. Let's say pretend this thing never happened. No one makes workflow architecture. What's it like? What does that mean to a workflow architecture? How do we just create it from scratch? And then how do we make one without over designing? How do we make one without, like, okay, I have a great idea. How do we make sure that you don't go too crazy about it? And then how do we convert your existing system, start adopting this, like, workflow architecture? In the end, how do you actually implement this in real world or in production? So let's begin with workflow architecture. Let's define it. So how I see workflow is that, to me, it seems like it's a distributed state machine. So if you're in CS, if you're in traditional background, you know, and one way or another, you'll come to this, concept of a state machine. I would say workflow taking a step further, where you put the state machine in the cloud, and each state you can do some triggers, to invoke some of the things that you do, some task, a lambda. It could be an API call to other places, but the high level is using this state machine type thing to orchestrate the work, the task throughout your programming lifecycle of software. So in the presentation, you will hear me using workflow and state kind of interchangeably, because in my mind, that's how I work. That's how I see it. I see it as a state machine in the cloud. So let's imagine you have to design an event system. Let's do a little exercise. Let's invent this workflow architecture. So let's say you're designing an event system, right? And a lot of people, they say, okay, well, I have a lot of events. For each event, I want to do 3 things. I want to collect it. I want to collect it. For each event, it will trigger something. And then we will have to do some filter and modification of the events. And then at the end, we'll have to send it out through a REST API. So it's a 3-step process. So some people say, okay, well, I'm going to start off with a messaging queue, maybe a Kafka queue. I'm going to queue it up, and then it will run a software which put into another queue where it does filtering, it does modification, and then at the end, I'm going to queue up to another queue where this queue is responsible to sending things out. Right? Sounds lovely and all, easy project. I'm gonna give it 3 weeks, PM's happy, EM's happy, everyone's happy, except you're gonna start seeing some edge cases. You're gonna start seeing event timing out. You're gonna see like, okay, how do I do the error recovery? Okay, how do I make sure it's event is idempotent? Like you don't want to send out 5 emails, instead of one. How do we make sure all this thing happens, right? And in a nutshell, this is what the workflow architecture a lot of the time provided for you already. Each stage you can think of it as a queue where you do one thing and you move on to another. You have a really good visual in all of workflow architecture software because you already see it. It's in front of you. You will have all the item potency, error recovery, retries, timeout already provided for you as part of the architecture. Because when you think about state machines, those are things that you can build in very easily. Looping into some state, make sure it's idempotent, make sure it's run at least once or more than once. So I see workflow architecture being a really good replacement in this kind of scenario or situations. So I'm going to go through a workflow rationale, which consists of 2 parts. Right? What does it mean to have a real good workflow architecture? So let's say now you've established that, okay, this is a cool thing. I get the idea, I get why we're using it. What is a good one? I understand this is a good concept. How do I have some examples to see how people perfect this, using this to do things? And I'll do it by explaining it in 4 parts. So these are the 4 characteristics that I found a good workflow, a good state machine have in common, right? And I will go through each of them with some of the examples that I see in real life to say, and some of the things that I see in my work that we do to create a very clean, very sleek, very streamlined workflow architecture, then you will see why they are so useful in a real life scenario. And a lot of this, I always tie this back to the hero's journey. I see this being almost like a reference to what a good workflow should feel like. If you haven't seen Hero's Journey, it's a way for people to, it's kind of like a template boilerplate for people to write like friction adventure story. And just like a good story can always trace back to Hero's Journey, a good workflow, a good state machine can always trace back to all these 4 points, right? And they have a lot of commonality in between. So I would say the first thing, number one, when you write a story, when you create a workflow, you will establish a main character. So what a main character is it could be anything, right, in a workflow way. It can be an event, it can be a reference to an object, or you can just pass an object along the state, right, have everything kind of pick it up and modify it and, maybe write it to the database at the end. But each of them, you should be really interacting with a single source of truth. Perhaps this source of truth can trigger things, right? Just as the main character could meet other people, could do things, could trigger, it has like side effect, has ripple. But ideally, you want it to be having one central piece of information, one central object that you modify. One prime example, one key example of this a lot of time is machine learning. A lot of machine learning use cases actually use workflow, if you think about it. Why? Because let's say you have a single data set and you have to do things to it. Right? Maybe you want to transform it. Maybe you're analyzing an image, right? And you might want to apply a couple of filters on it. You might want to extract some information and write it to the database. But you're always interacting with this single image. You create the whole workflow, the state machine, with the ideal of processing this one single image to the very end. It was never, 3, 5 images. It's never a batch job. It's this one thing that you're trying to do, one task, one whatever, and carry it through. And now that we establish a main character, the next thing that is very important is to know where the character starts and where the character ends. One example of this is, let's say you're building a weathering alert app. Okay, and maybe this weathering alert app has to, collect all this metadata from weather, like humidity, rain, so you have states to, collect this information, collect that information all the way. One thing that you don't want to see in a good workflow is that it just fans out to be like 20 some states or 50 some states, and each of them corresponds to a tiny task. Maybe, oh, if it's rain, you do this, and if it's thunderstorm, you do this, and you have 50 some states at the end, and they are all the final states. Okay? Why is this bad? Imagine you're the next developer, Paul, let's say. Paul came in and say, okay, well, I'm ready to extend this state machine. Wonderful idea, wonderful concept. I just love this. Where do I start? And they say, well, Paul, look, this thing start here, and boom, it ends at all different final states. So in order to do it, you must bring all this fan out state back together into single states, right? If you have states that's really fanned out, it becomes really hard to extend from it, because now you have to bring out some states together. When you need to extend it, you have to think about the state machine, the workflow, as a growing, software. It never stops. If there will be new state, there'll be old state, there'll be state that get modified. You have to think about Paul. You have to think about the person who comes after, and the one that interacts with the step function, the state machine, the workflow. The other thing is the clear beginning, right? If your state machine can be triggered in a million different places, how do you control what goes into it? It's really difficult. You really want to have this state machine, this workflow, to be pretty specific. You don't want to make this one generic thing that runs everything. You want to make it really specific and be able to trigger or initiate in very specific places. And by doing so, you can then control what goes into your workflow. Because like I said, workflow gonna grow. The last scenario that you want to do is to debug this giant nested tree of mess, and just to find that one state that you want to modify, and found that you cannot, because 30 some states out to say does not provide the information if it gets triggered in this random code path that only 3 people are using, and because of that, you cannot do anything with this the state machine. So ideally, you want to keep this small, you want to keep it specific, you want to keep the beginning and the end very, very tight, like a tight loop. And the next one is you want to prepare for failure and pivot possibility. So that's where the plot twist and the story, plot twist coming from. So what does that mean? I have to reference back to one of my old coworker. He wrote a really an article around what's a good design? What's a good design doc looks like? And he said, whenever you design doc, and if I don't see 40% of the design doc cover what could go wrong and how do I fix it, he doesn't even bother to read it, right? Why is that the case? Because if you think about it, most of the events, most of the things that you cared about are not the ones when the code runs perfectly fine. You just expect it. That's something you know is going to happen. Usually when things get really wild and out of control are things that when you fail, because when you fail, it can fail all the unexpected ways. In a good workflow architecture, you really take that to heart, because you want to say, look at it and say, each of these states, okay, how could they go wrong, right? What could go wrong? And when they go wrong, what do I do, right? And I always list the 3 bullet points that you always can do when a single state goes wrong. You roll back, you undo whatever changes that you have, you capture that error, and you communicate externally. So this example, for example, why is that the case, right? In e-commerce, a lot of time when you buy things, if something go wrong in the post-processing, they just cancel the order, right? They say, well, we cannot fulfill that, so we're gonna cancel it. Let's say if I don't do one of these things, if I don't do rollback, well, the order kind of still in this fuzzy state of maybe they charge it, they pay for it, and we never return the money. What does that mean? Angry customer. Let's say you didn't capture the error. Someone call the CSA, well, we refunded, and they ask, okay, but what was wrong? And you can come up with it because you didn't know, you didn't capture the error. You didn't say, okay, what is wrong? So the CS is like, oh, I don't know, I have to go look. And that's an angry customer right there. And the last bit is, imagine you're buying a toy for your loved one, for your kids or whatever, or you're buying a lovely gift, for your partner, and they got canceled. And 2 weeks later, the customer finally find out it was way past Christmas. And what happened, And so you want to like externally communicate if there are any stakeholders that's interested. That could be some people, that could be another service that needs to know there's a failing event. Whatever it is, you want to be able to at least do these 3 things. And some people might ask, okay, well, what if I just have one fail state, one error state, like just capture everything? Like it does these 3 things perfectly. Okay. And let's say there are 10 different states, in your system, and each of them could possibly has 3 different errors. It could, error 1, error 2, error 3. If you think about it, what is the combination of all the states, could fail differently? Now, this is 3 to 10. Well, that's an insanely big number, right? Like, but that's all the combination could fail. And you have one state to capture all these things. Is that reasonable? I mean, I'll let you to decide, but I wouldn't decide to something like that, right? But if, let's say you have an error handling state for each of your states, each of your 10 states, each of your error states just need to handle at most 3 errors. So be a little more detailed when it comes to handling error, which will really save your butt in the long term. Because if you only have one error state, remember this, the possible of error combination grows exponentially. If you have one error state, or if you have very minuscule detailed error states, then the combination of errors that they have to handle is a lot smaller. So meaning a lot less if, else, then code path in your error states. And the last bit is more so a human factor, and that is to keep the cost low. And the cost of this is not, okay, how much money we're going to spend on this workflow, but more so how expensive or how timely it is to create a new state or error state or to even create a new workflow, right? Imagine this situation. Let's say Paul came in and say, okay, well, now the beginning and end looks very good. I'm ready to make a new state. And Paul say, okay, well, let me read up documentation on how you guys do things. And you guys use an in-house workflow software and say, okay, well, I'll follow that. And they say, well, Paul, you have to, spend like maybe 3 weeks on this and write like 1,000 lines of code and 5 new files and all that. What would Paul do in this situation? What would you do, right? You'd probably say, okay, well, it takes that long to make a new state, but it really takes an hour to write an else if statement in the previous one. Right? And if you were me, I would do the latter. Right? And that takes like 2 hours to do. You always, do whatever the path of least resistance is, right? And that's what's gonna happen. If you make it really, really hard to extend your workflow, then no one is going to make new state. Your state machine will look very, very sad because you have tiny state, one existing old state that encapsulate all the logic that's supposed to split into 20 different states, and then the end. You will have something that has 4 things to it, right? So make sure to keep the cost low, and that way, you know, people that comes after you, they will have a better time to use this thing that you created. Now you've seen good things about a good workflow architecture. Those are characteristic. When it comes to designing one, here are some pitfalls that you want to make sure that you don't go into. Here's some guidelines that when you say you're designing, how you go about starting it. One, talk to your business person. Why is that? Well, workflow architecture tends to go hand in hand with the business flow or user flow. Some people call it life cycle, status, states, experiences, all those things very tightly. Because after all, you're designing a program that processes things, and as human brain, we break things up, very similarly. We break things by part very similarly. So go talk to them and ask them, what is the flow currently today looks like? And maybe your workflow could just look identical, maybe with little modification. And the one benefit that comes with it is that, when a PM comes in, and a lot of the workflow has visual, so they will look at it and say, wow, I can understand this. Why can they understand it? Because, it looks just like the thing that they have on their desk. So one time my PM came to me and told me, it's like, Ed, this thing that you did, this workflow thing you did, this looks amazing. I was like, oh, how so? Like, what? I'm glad you're using it. I was like, well, I'm glad you're looking. He said, the other day I found something was failing. In the past, I have no idea how it failed, but with this workflow, it encapsulates every step of the e-commerce that we have in our mind. And he said, well, and then no, this thing failed before we captured the payment, we charge people, and this has happened before we ship anything. But this happens after someone checked out. So they know exactly what part of it, which step of it exactly is failing. They know which part of the funnel is exactly having issue without me even telling them. And this is kind of the most streamlined communication we can ever have with a business person, right? Without your help, they can go into it and look at what is wrong with the system. Then you build a really good system because they don't need explanation. The other thing is, that's kind of tie into what we talked about before, that is like kind of similar to the business flow, is that you want to group the states. You want to group the states in the workflow together by its purpose, by its form, not the function. So here's 2 things you can do, right? This is 2 scenario. If you're building like this robot thing, you can either say, okay, I want to move my left and then move my right, left, right, left, right, left, right, and then you move your hands. Or you can say, I walk n times, and then you do a wave. Well, both cases is possible, can be done in a workflow, because after all, it's a state machine. And in the past, if you're building a state machine, your teacher, professor, your mentor will tell you, don't do the second case, do the first one. Right? That's what a state machine is for. It's a program. It's a computer program. You have to give it command. You have to give it, those are commands. But workflow architecture, the biggest difference is it's an orchestration tool. You do not want to program with workflow. Can you do it? Yes. Should you? No. Never try to program with a workflow. Use it for what it's designed for, an orchestration. So make states like walk, have the programming logic go inside the programming language. Program walk inside your endpoint. Then you can call that n times to walk n times. Program something called wave. And then you call that state wave instead of just making endpoints to move left leg, right left leg, right legs, and then repeat that n times. Because in terms of look at when the PM come in, they don't understand what it's trying to do if you do first case. If you look at second case, then they know exactly, oh, you're trying to walk n times and you wave. That's brilliant. do it, group it by its form, not its function. Group the states by their purpose. Okay, not the command. And the last thing, what about like, when designing it, think event-driven, think asynchronous. So these are like, whoa, keywords, hot words, right? Like these are the buzzword of like, kind of this year, last year, this decade, event-driven. But it's true. Workflow is a highly event-driven, architecture. My favorite thing to do with workflow is this block state that I use where, I store a token somewhere at the very beginning of the state, and there's someone who grab the token, go out and do something, and we then return the token when the task is done. One example I'll give to people is that, let's say you're writing a restaurant software, and the states will, you have all the states to provide services, to fill the water. I don't know how it is in the UK, but if you travel in the US, you know that waiter or waitresses, they come harass you every 5 minutes and make sure, you're still okay. Make sure that you haven't choked on the food, you have enough water, the AC is in the right temperature. I didn't know it was a very US thing, but and then I read it and I was like, oh, why is my waiter and waitresses come harass me every 5 minutes? I can talk to my friends. It's kind of funny, but imagine you have just a state, every 5 minutes, go check on customer and all that, and at the very end they have to pay, and then in the US, how it works is that you give them a card or you give them a tab or a check, and then they put the card in, and then you have to wait for them to put the card in, and then you pay. And this is like an event-driven thing, right? And if your software will have a state to say, okay, do not execute past this point after someone paid for the deal, then execute, maybe greetings, say goodbye, and give souvenir or whatever. In order to do that, you can just say, okay, I give someone else a token, and then after the payment is processed, the payment process software will send the token back, a little callback to the workflow that you have. Then your workflow will be unblocked. So you can imagine your workflow could be filled with all this blocking logic of, if this happens, wait till this happens, then proceed. Wait till this happens, then proceed. Wait till this happens, then proceed. So this whole thing can be asynchronous, and it's very event-driven. Cool. Whew. Now we learned like 7 things about like, okay, workflow should do this. Okay, workflow should do that. And I also given you, plenty of examples of, like what is it like to have a, good workflow, and like all those use cases that you can apply this on. I hope I got you all aroused up and say, oh man, I'm gonna go home, I'm gonna tell my boss, I'm gonna rewrite everything. I'm gonna start from scratch. I'm gonna, make every single thing workflow. If you're thinking like that, then I'm doing a really good job, because that's what I'm here for. I'm here to inspire you to say, this is a really cool concept. I haven't thought about this before. I want to start using it. Well, if you feel like that, then this chapter, this thing will really help you to spot area, to spot location of places, to say, well, this is a prime example for you applying a workflow architecture. So, piggyback to what I mentioned before, workflow is probably the most prime example of event-driven, right? Because if you think about it, how do you trigger a workflow? You trigger a workflow by having something happen. So on the right, this is an example of actually what fast post-processing workflow looks like. So this is a real live production. It's running right now. It's Black Friday. So we have like tens of thousands of this running in the background right now. It's in production. So, and it's very event driven, right? So you start off, whenever somebody create a cart, when you start going to shop, you'll create a workflow. And the first thing you realize is that order in car state, right? What does that mean? It means that it just blocks until someone complete the checkout, they complete the purchase. So even in the very first state, you will have a state that is event driven. You're waiting for somebody to do something and then say, okay, I'll move on. Either it takes too long for someone to check out, so I just clean up whatever shopping cart they have, or you go on and they finish the checking out and you go on processing. Right. And look at all this. Like in here, I can tell you there's at least 4 more places where we are waiting for some events to happen. Maybe we're waiting for the fraud check to finish. Maybe we're waiting for someone to change their card to make sure it's finalized. Maybe we're waiting for the payment to come through, right? So workflow is a prime example for event-driven. If you're seeing places in your code where you have like message queue, sort like, when there's like events happen, you put things in message queue and all that, you know, start thinking about it. Start thinking it's like, okay, maybe this can be done in a workflow. Another thing is repeat, waits, and all these other operations, heartbeats, right? Timeouts, and all that. Like if you see that yourself doing a lot of these kinds a lot, like actually programming this kind of logic a lot, maybe it's a good time to start thinking about workflow. Because in a workflow architecture, this kind of stuff are defined in the software already. So on the right, you can see all this loop to different states. Excuse me. I did not really have to program that, right? I just write out what number it is, like how many times, what states it goes to, right? So instead of writing these loops of like, crazy logic, maybe in a message queue, you have a orchestrate queue where the queue will put it back into the right queue. Instead of doing that, there's a much cleaner way to do it. To do repeating, to do waiting, to do like timeout, heartbeat, to do exception. If you see yourself start doing like using like message queue or crazy things to start doing like, this kind of retry things, stop. Think about workflow. Think about workflow. One thing that I did in my past job actually is exactly that. We built a 4-tier message queuing system, and we have like all this message queue. It's starting getting really complicated because you have queues after queues. Like we like end up like 13 or 15 queues, and we don't know which queue to queue things up. So you have a queue to just for queuing things up, and it's a mess. It's a mess. Don't do that, right? Don't repeat my mistake. Start thinking about workflow. The next thing is recovery, right? So, like I said, well, sometimes things failed, and you wanted to be able to, for example, pick it up back in the same state. So maybe you want to have some retry logic happens. Uh, Maybe you want to just start from scratch. So in the retry, a lot of the workflow they can specify, oh, if you have this kind of error, retry it this many times with this many times apart. Or you would say, allow some of the workflow to say, well, you can only have one of the same ID of the same workflow running. Meaning that if you really want to encode your idempotency into your workflow, you can just encode it into the ID of the workflow. And then each time it starts, restart a workflow, there's only one of those, running on the ID that you provide, which naturally gives you idempotency. So workflow is really great at recovering and restarting some of the process that you have left off or it has failed. Asynchronous versus synchronous. So one thing that you should not deploy workflow to is that I have heard somebody to say, well, I really love workflow, and we use step function in AWS. And he's from AWS, so he's like, okay, I want to, we should use this for everything. And so, okay, well, I mean, I like it too, so I talk about it. What do you want to do with it? Like, okay, imagine this. Someone hit an endpoint, and they at that point will just start, a workflow. We start a state machine. and then we'll just wait on the endpoint, and then until some results came back, and then we just wait on it, and then we have this asynchronous process in the background just keep running, and your endpoint will just keep waiting. I was like, that is crazy. That's madness. Why would you do that? That's silly. That's so silly, right? Like, if your whole process is synchronous and is expected to be, right, there's no point to use workflow. So there's one places that you shouldn't do it is that, let's say you have an endpoint, you expect the result just come back quickly. Do not use workflow in these cases, right? Workflow is supposed to be very asynchronous. It's for you to be like a processing job. It's supposed to be on the background and all that. It's not supposed to be, synchronous. If you have a simple endpoint to do a get, do not start as, a workflow. It has two states, and where the second state will be a get and send something back to a different endpoint. Like, no, 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 no. Keep it simple. If you're like having some async process, normally it's probably a good place. If you're synchronous, normally you have to think about it. You have to think about if this synchronous process takes a really long time or something, then maybe it's not some good place to be to use workflow. So let's talk about like real world implementation, right? Because now we've seen the architecture, we have seen the good reasoning, places to convert it. One thing I feel like you're really missing now from me is, okay, well, I want to start. And if you rewrite the whole workflow architecture from scratch, you're redesigning it. I mean, ultimately, it doesn't do you any help, right? What are the existing things already exist today that already does all this retry, repeat logic, and all you have to do is to go in and program a few states, and you start getting running. And this is what this chapter is about, is, what are the existing tools. So I'm going to start with like the one that I'm most familiar with. This is the AWS step function. And you can see here, it can go out and call Lambda. It can, go out, and there are like different states of waiting, that. Number one is cloud, it's on the cloud, so you configure everything on the cloud. You can configure it locally. You can deploy it, very easily. It's a plug and play, and it works out with all the integrations that they come with, right? Like if you use AWS, you have Lambdas and all that stuff, right? It works really well with all those integrations. And Google Cloud had their own spin of it called workflows. And in this example, even the prime example is that you can have a little if statement. You can see this being very like a business flow, right? But really, it's an orchestration to run some of the logic in a separate place in the endpoints. I know there's a Microsoft community, so this is probably the most closely related. We have Azure Logic Apps, which is like Azure spin-off the workflow architecture. And I couldn't find an example picture of like how to define it, but you can see that it has, again, great like integration, right? You can start a logic apps with another logic apps. You can get data directly from all these places through the gateway, connect to the database. Or a lot of the times, people use the Azure functions like serverless. And then you can see that a lot of this they support with machine learning. But again, machine learning is just one small use cases of this. A lot of places can be benefit with like workflow. So let's say you're not really like fond of cloud. You want to do things locally, because when it's in the cloud, it's really hard to mock things, really hard to test things. It's really hard to like have it locally and write unit tests. That's almost impossible. Like, what are the options, right, for not doing it, in the cloud? How do we do it locally? There is a SDK called ELSA, and ELSA is, I believe it's open source. And the idea there is that you can define workflow locally and also run it locally, and also have all this definition in the in the JSON or in code. And that's another benefit of having this kind of stuff locally, is that you can define the workflow in code. Right? It's more like coding, like more programming language, like versus giving a JSON or YAML template file. I put Elsa here having an honorable mention is because it's in C#. So unfortunately, that's not a lot of local workflow SDK that support the C# languages, or .NET or in that suite. However, Elsa is one of the ones that primarily used with C#. And the last bit, the last one that I'm going to recommend is Temporal, and this is developed quite recently. It's one of the newest startup there is, and it's formed by the team that used to manage the workflow software in Uber called Cadence. And if you heard of Cadence, they're the same people who make Cadence. They split out and make Temporal, and they have SDK that go across many languages, and they're rolling out more supports over time. And it's very feature rich. Anything that you can do in the cloud, you could probably do it with Temporal. It's a lot of freedom, but again, a lot of the integration that already exists in the cloud environments, you will have to build it yourself again. So it's not the most friendly in that sense. However, you can test it locally. You can do a lot of great things locally, and it's well maintained and keep growing. So Temporal is probably something that I would watch out for if you're looking into doing a workflow architecture. I'll either go with Temporal if you're just building it out in a project, or if you're already in a cloud environment, I'll look into some of this cloud software that already exists, because it might really easy to integrate whatever ecosystem you already have. For example, if you already have Lambdas running, right, that triggered by message queue, then you can replay the message queue immediately and just and in place and put it inside the Azure logic apps in there, and just go out and call this Azure functions already that you already have. So depends on what you're trying to do. These are all very viable options. And read up the documentation. There's a barrier to get in because it's almost like their own language. But once you get used to it, it's a smooth sailing from there. Cool. So that wraps up the end of my presentation. If you make it to this point, kudos for you. I get tired of hearing myself talk sometimes, so you spent all this time to hear myself talk. Really thankful that you stayed to the end. And I hope this has a little inspiration. I really hope that you start understanding the workflow. Go ham with it. Workflow that creates workflow that creates workflow. Take those advice and comments and opinions in your head, and go ham. Thank you.
Yeah, it's just Mike dropping back in. Thanks for that. Just a quick note for anybody who has a question, feel free to pop it in the Discord channel or any feedback. We'll keep an eye on that. Ed, you've got some awesome slides in here. I love some of the graphics and stuff that you've got. It's really engaging. So a couple of quick questions from me while we're just giving people a chance to chat. So which workflows do you tend to use on your day-to-day basis at the minute, Ed, out of all the tools you showed?
Yeah, so we are an AWS shop, so the step function is the one that we tend to interact with the most.
Right.
But we are, we're considering options, right? Temporal is very fresh and new, so one thing that with step function, the biggest thing that we didn't like about it is the ability to test. Right? When you have a production app, when you have all this scenario with workflow, for example, you have error states. Sometimes it can get difficult to trigger when everything's in the cloud.
Yeah.
So we're looking into something that maybe is more locally testable, but is still playing with it. Right now, more one step on.
That's really cool. I did like the bit at the start where you were talking about how to describe the sort of story like analogy about describing the story of what your workflow does. That's a really good way of looking at it. Do you find any challenges when you work with people in your business around doing stuff like that? Sometimes I do similar things myself, but I sometimes find it's quite challenging to get people to engage around the workflow, and so a lot of the time people don't really understand the value of having that story. They just want, I want a workflow that does, and you get a one-liner kind of thing.
Right, 100%. Yeah, I think the biggest challenge is definitely the buy-in, like you said. I mean, we are engineers after all, and people are like, they don't like to not have the control, right? And then they will say, well, I can build this with like 15 message queues. Why do I want to use your little like this widgety thing that does all these things for me, right?
Yeah.
And to that, I always give them the same example. I say, well, don't listen to me. Don't even look in the workflow. Build it out, right? And then I will ask them question. Oh, well, don't you want like timeout and stuff in your queues? And they're like, oh yeah, I would want that. Well, there you go. You just make workflow yourself. Right? So they have to kind of rediscover it themselves. And I feel like that's the best way to convince your coworker to start looking at things this way.
I think the other thing maybe is the some of the stuff like that. It's the supportability of your workflow as well, isn't it? When we think that somebody else might pick it up in 6 months' time, and that you've got the combo of the visual designer, the story describing how it works, the testability. I think that's always one of the hardest parts about workflow solutions is when you haven't touched it for 6 months. How do you know how it worked and what it's supposed to do?
Yeah, no, this is for sure. I would say keep all your states small. First make sure your states is well defined, right? Tell a story, right? Like your state should be a story. You should be able to see the journey of something. So you get a high level of like, okay, there's all the things that it must go through. One slide that I left out is that I always tell people to keep all your code together in one place. Having workflow give you freedom of, and this is go with message queue or any sort of like an asynchronous event-driven system. You have the kind of freedom to say, I'm going to make some lambdas, I'm going to make some call functions, I'm going to make some of this, I'm going to make some of that, and you just have a scattered set of everything. Right? And to trace down on a single workflow, a single lifecycle, you have to go to like 20 different files. Right? This is very, very annoying to do. So keep it in one place, keep it in one folder. Sometimes like small things like this, organizations could just help to really understand it. So.
I guess sometimes as well when you talk about breaking out your states, sometimes you find if you don't do that, you end up with like code in them, I guess, don't they?
I think you're cutting out. Or is it me?
Oh, sorry, I was just saying, if you do, like I like the way you talked about separating the states out from the workflow, so that, like if you don't do that, sometimes you may end up with like 20 different. The robot, if you do like walk as a state, and then you have your workflow calls walk, I mean somebody else can use it as well, can't they?
Exactly. Yeah. No. Yeah. I think that's like the biggest pitfall I would say for engineers to create workflow is to try to write a program on workflow, right? So make sure to use this to more an orchestration, not programming. It's not a programming language; it's an orchestration tool.
So what kind of things are you excited about learning next, then, Ed? What techs are you sort of checking out? And
yeah, so I mean, I think like one thing that I definitely want to do in my current job is want to expand this workflow architecture. I mean, everyone see the flowchart that I've deployed, for my existing company, and in terms of e-commerce, right, it doesn't catch a lot of edge cases. So that's something that I would like to do is to expand it. And the other thing is, this is kind of minuscule details, but there's always a constant debate of. So since it's an orchestration, one thing that you don't get a lot is you're missing, I would say, is the context between the states. Yeah. So you either pass by reference and you use a reference to retrieve the copy from somewhere, But that could be a timely process, right? Because that would be, let's say, a 50 state, that's at least 50 reads. Or you're passing the copy that you're modifying, you write it at the end, so you don't one read and one write at the end, but you're at the risk of losing, maybe like you're falling behind, maybe someone else modified it, and now you have like conflict and stuff. So we are designing a system where we could hopefully mitigate some of this, minimize them really right, but also not at the risk of like losing this transaction property of things. So smaller project,
Okay.
but big improvement.
Yeah, sounds cool. I think we haven't got any more questions in Discord at the minute. Will you be able to check out? Just keep an eye on the Discord channel, Ed, afterwards if anyone wants to come and have a quick chat with you about anything.
Yeah, I'll be around. Ask me anything. Like, I'm obviously talk about workflow for an hour, and you probably think that I'm a madman. This is all I want. This is like my life's passion. But
it's a topic I'm really into as well, mate. So I've enjoyed that presentation. It was really interesting.
Okay. Yeah. So, but I'm free to talk about anything. So I'll be around Discord channel. Find me, just about anything that you like to know.
Brilliant. Thank you very much, Ed, on behalf of the audience. And I hope you get a chance to enjoy the rest of your day, Ed. Thanks everybody for listening. I think that's pretty much the last sessions. I think, if I remember right, I think that's the last sessions of the day. I think there is a wrap-up meeting if anybody wants to join that. I think the link's in Discord for it. But huge thanks, Ed, on behalf of the audience there for joining us today. And I hope everyone has a good day. Catch us all later.
Awesome. Well, thanks, everyone. Bye-bye.